I'd now like to open it up to people to ask questions. We'll kick off with the first question being for Hugh. Can you comment on the relative value of lots of fairly uncertain data, for example, remote sensing, relative to precise local data, and how we might best understand these relative strengths, for example, to do better water accounting?
So I think there are pretty well understood probabilistic frameworks for balancing uncertain information with highly certain information, and also I have to say with existing models, and those models may not just be mathematical, but they may be expert opinions and things like that that you'd all like to bring together. And I think probably wouldn't be too far away from the organisers by saying that Bayesian methods probably underpin a lot of those techniques, and it gives you a very direct measurement of the value of an individual piece of data on a model and the precision that you will get in that parameter or model estimation. So there are surprisingly quite well known mathematical techniques. Are they widely used? Not as much as they perhaps should be. And looking at Eric here, they're often used, for example, in, let's say, mining to decide where you might take the next drill hole in order to maximize the information about an ore body, as an example.
There's a question for Eric. I understand that you are in the mining wing of Newcrest. Do you have any comments on how the precursor data sets, exploration and mine planning, interact with the operational data that you're using?
Yeah, and look, a fantastic handball from Hugh just there as well that sort of touches on this one too. The idea of purely the theoretical sense, I mean, you can imagine information-based sensing. It's been around for a while. As you generate more information, you can build an estimate of where you actually are more or less certain, and you can target drilling, for example, in areas where you want more data. In theory, things like that have been around for quite some time. I wouldn't say they're necessarily productized yet, but that's one of the big problems I find within the industry. There's a lot of bespoke solutions rather than product level solutions. But the answer more generally for the use of that downstream, to be honest, I didn't touch on it too much in the talk, but it's very much the same answer as the information you generate in the pit. Yes, it can absolutely add value, I think, in operations and flow all the way through. In practical terms at the moment, though, I guess it's not necessarily the norm in all operations. I mean, a lot of the time that prior information from exploration is used to build your original block model, and then people tend to stick with the block model that they have. But the original exploration level data, a lot of that is really rich and could absolutely provide value downstream. That's sort of one of the challenges I'd throw out there, that I think getting the right tools in place for the business to be able to consume those and actually do it effectively is something that would be really interesting to look at.
Just a follow-up for Eric on automation. Do you think sort of maybe the value of automation, or a large part of the value of automation, is not just sort of cost reduction, but it is in fact the reduction of uncertainty? Or is it? I mean, with automated mines, do you have less variability than if they were unautomated? And is that part of the value of automation?
My view, absolutely yes. Automated systems do what you tell them. It reduces the variability in terms of the outcome. You would get a far more controlled process. I mean, ideally, you'd get something you could set your watch by. If you make a prediction of what you're going to move in a given day, yes, the automated systems could do it. That's absolutely, I would say, one of the biggest success criteria you'd be looking for.
Thank you.
So Sally, I wonder if I could ask a question of Julie and Jim together.
Yes, please do.
I mean, one of the problems that we faced in our office, and I'm sure you do too, Julie and Jim, is the problem of managing uncertainty about climate change. Because in the end, it drives so much of what we do: forests, fires, water, and everything else. And yet, as I was saying in my talk about different types of uncertainty, it's not straightforward uncertainty. It's about models, it's about possible things, it's about lots of stuff. How do you genuinely, Julie, let's start with, bring that into your decision making?
We do a couple of things. So first of all, we have quite a significant body of natural perils scientists that sit within our organisation. And we're probably one of the few insurance companies that do, and we make sure that they're capable of covering the range of perils, but with a particular focus on climate-related science. And so there's a lot of collaboration that occurs between them and various other research centres, universities, both in Australia and globally. And so we're trying to make sure that we are understanding predictions and trends that are sort of extraneous to our organisation. When we then, and so they help us build, and keep in mind that when we're trying to predict climate, we're always pricing a risk over a 12-month period in an immediate sense. They help us price the natural perils costs into our contracts annually, and they also help us determine that capital equation that I sort of referenced a little bit earlier. When it comes to decision making, it's interesting. So we are continuously now embedding, from a risk point of view, a perspective around what some of that significant uncertainty and what some of those risks might look like into the way that we do our strategic planning. And so when we are looking at business planning and growth plans over a certain time horizon, we're now bringing that scientific view to the table to say, okay, well, if we have a plan and there's an opportunity for us to grow in Southeast Queensland, just making this up, or the Northern Territory, and we think those areas are most vulnerable to future related risk, what kind of pricing do we need to take into that market, and how do we send those signals over the longer term? And so that's a pretty critical part of our planning. We also spend a lot of time with government. So we do a lot of work with government around, we are understanding the vulnerability of these places. These are the types of actions that you could take to mitigate risk, whether it's to better protect homes, to change or raise dams, to improve building materials or the types of materials that are used, or to educate the community about the risks of the area that they live in a different way. We spend a lot of time trying to influence government ultimately about the choices that they make as well. So those are some of the areas.
Jim, what do you think?
Well, because if I was being flippant, I'd say, well, we asked the chief scientist to tell us how to take it into account.
Yeah.
But one thing that we do, we're developing regional water strategies that tell us what water should be available for 12 regions across the state, and how that water should be managed, and what solutions we need to put in place for changes to how the water needs to be managed, or what water is available, and so on. And those strategies are based on climate modelling, which Hugh's team has helped us with. But if we take that down another level, we have water sharing plans, which are a bit more local and a bit more here and now, that tell us how we share water. And they have to take into account the drought of record, or which drought we should be taking into account in those water sharing plans. And judgments around those need to be made as to what does the climate data and the climate modelling tell us, and the paleoclimate work that has been done about which droughts we should be taking into account when trying to make assessments as to how to share water in a particular valley. And then another thing, I think, where the climate thing comes in, or should come in, I don't think does yet, we need to understand what impact climate is going to have on not just how much water we have, but the type of water that we have available to us, by which I mean, is it all stormwater now? Because civil engineers forever have been avoiding capturing stormwater because, when they did their civil engineering education, it told them that that was a more expensive way of managing water than collecting water by other means. But if the only water we've got available to major cities in the future is going to be from very heavy rainfall and therefore stormwater, we've got to find ways of harvesting stormwater, which at the moment are not fitting into the way we do things. So I think in terms of how we're doing our water sharing planning, we're building climate modelling into that, and we need to get better at that, and we need to reflect from the regional water strategies, which take a longer term view. Do we need to make any changes to the drought sequence that we're picking? But how we plan for water supply for cities, I think we're going to have a fundamental shift in our thinking in the future, about what type of infrastructure solutions we put in place, and we're going to have to harvesting stormwater in some places in a way that we've let it go up till now.
Yep, agreed.
Did I get that right?
Yep, I would say it was good, very good. I'll give you a pass.
Oh, a pass.
Okay.
Well, that's good
Right.
in my book.
So there's another question for Julie. Are your probabilistic models for natural perils based on current climate, say 99 to 2020, past climate, say the 20th century, or future?
Good question. It depends on the peril. So, and depends on the data that we have available. So with earthquake, we're looking at a time horizon, a historical time horizon around actual earthquakes and damage that goes backwards, 100 years to the extent that we can find it. But we're also looking at predictive models that are looking at the probability of earthquakes happening, out over that time period. The challenge is often determining what the value of the asset is. So if you're looking backwards on an event, and there's a certain quantum of loss that's occurred, what does that quantum look like today? If we're looking at cyclones, we're using a much shorter time series. We definitely look backwards, but there's a higher frequency of cyclones. So we're sort of looking over a historical loss of sort of 10 to 20 year time period, but we're increasing the frequency factors based on what we think is going to happen around our climate. And if we're looking at storms and in fact bushfires, which are extremely difficult to model, there really aren't any reliable probabilistic models around those. We're often trying to take a view using much more contemporary and current data.
I've got one for Jim. So a lot of your talk, and it resonated with me, was, that people seem to rush to certainty rather than sort of embracing uncertainty and learning about how you can diversify some of it away and some of it you can't. So you sort of need to be able to manage it and live with it. So could you say, so this must happen a lot in water in DeepI. How do you in DeepI convey this notion of uncertainty and trying to manage uncertainty? And, data is not all about just making uncertainty go away, but actually trying to quantify it in order to manage it better in DeepI, if you could comment.
Yeah, thanks for that. Look, I think we don't do it very well at the moment. And one of the reasons for that is Hugh referred earlier to community engagement. One of the things in engaging with our communities about water allocations and things like that, people want some certainty. And when we're dealing with a very uncertain set of circumstances, if it comes across that we are uncertain, we are unsure, that can be quite difficult as a message to communities. And I think we've got to get much better at how we do that. Where I think we can approach this better, I think, is working with the utilities that are providing town water. In the example that I use with Hunter Water, I think there's vast expenditure that potentially could be saved or redirected or retimed or what have you, if we were to embrace uncertainty a little bit more. The problem is, and when you sit down and write your risk appetite statements, as we all have to do, on some levels, risk appetite statements help us focus on the things we really need to be managing, and that's great. But if you're in a water utility and someone says, what's your appetite for Sydney running out of water? How am I going to say it's anything other than zero? And how do I manage the amount of uncertainty that actually equates to zero risk appetite? In the Hunter, we looked at that situation and said there were those on our team and on our board saying, shouldn't we be saying we have no risk for running out of water in the Hunter, and therefore we shouldn't be trying to keep our options open, we should be trying to build certainty? And that was a really difficult conversation. We did it qualitatively rather than through any quantitative means. But I think, tools that would enable us to understand that kind of system better would be really powerful. And it's really hard to say, I don't think we should be having risk appetite statements about safety of people and risk of running out of water and so on. But once you've written them down, they're really hard to come up with an equation that says, well, we'll just wait and not build that bit of uncertainty yet in terms of Sydney's water supply or whatever it might be. Where we got to in the most recent drought, had the drought carried on for a long time, we would have had no option but to have built more desalination, and we were actively planning for the expansion of desal. But the rain came along that has given us enough time to pause that expansion while we can consider further. But it's not a comfortable place to be in, because it's pushing our risk appetite thinking to extremes. So I haven't really answered how we do it. I've more told you about why it's so difficult.
No, I agree.
That's the problem we're grappling with.
I was asking because I'd like to know how to do it. I mean, I think that's one of the hardest things, is to actually be able to convey it and to put probabilities on it and not scare everybody.
Yes, and you know, when you think that Moody's, and this was written about in the press, so I'm not sharing any secret here. Moody's considered that water security risk was one of the biggest factors with the potential to affect the credit rating for New South Wales. You don't want to be messing around with this thing. You don't want some joker like me saying, I think there's a value in keeping our options open. That's not necessarily what people want to hear.
Yeah.
But on the other hand, there is a value in keeping our options open.
Yes, of course.
And I think, therefore, the narrative should be about what proportion of our water should come from climate-independent sources, rather than how much risk should we take of Warragamba Dam not having enough water to go around. And maybe that would help us with a better way of thinking.
I've written down your comment about climate-independent water sources. I thought it was a very. I'm not sure that it's possible. Is it possible?
Well, at the moment, the desalination plant we have for Sydney can meet 15% of Sydney's demand. I think Melbourne probably is covered by about 30%. So you can just keep building more and more robustness by having more and more desal or more recycling of treated wastewater or whatever it might be. So yeah, you would say you don't need it to rain for the desal plant to work, but the energy requirement, the environmental impact, and all that stuff, and the cost, you have to say there's probably a better equation than just going to higher and higher and higher.
Yeah, well, we sort of clearly need multi-criteria objective functions, because there's just running out of water. Yeah, so I think that unfortunately we are running out of time.
Yes, we are close to time, but your closing remarks were planned for about 15 minutes, and I think you're only going to do a few minutes. So if you have more questions, you've got two more questions, Sally.
Okay, all right. Okay, I'm going to ask Julie. Sorry, Hugh. I can, but I will come back to. But so I was intrigued that you know, you put up that graph, which is very powerful, about just how much natural, you know, the cost of natural disasters is increasing at such a really quite an alarming rate. And I wondered, you know, how often does IAG or an insurance company, how often do you redo your models to reassess all your risks? You know, are you doing this sort of, you know, once a year, once a month, so at what point does it become really important for you? Because the world is moving and people are changing very quickly.
Sure.
I feel that there's much more change now than there was.
Yeah, it's a good question, and it really it depends on the risk. So if we're trying to look at and it depends on the currency of the information that we're able to receive, the data that we're able to receive. So I think it'll change as we go forward. But there are some models that we're rerunning as a customer interacts with us, say, daily. So they might be components around shifting attributes of that customer that we then come back and retest against sort of our models, so that we're giving sort of an update, and we're using that data then to refresh that model. And that might be happening daily. As you move further down the time horizon of the likely impact of some of the risks that we protect, it's less frequent. So we would run our catastrophe models. Well, we might run them for a certain reason, but we might rerun our catastrophe models and our perils models once a month. We'll do one very big rerun once a year. And that's where we just go and pull the models apart and check everything again to make sure there's no changes or anything we don't understand.
Okay.
With climate, we're trying to be more contemporary now. So we're trying to look at whatever insight we can around the likelihood of climate impacts and trying to refresh that more regularly. But that's still sort of every 1 to 2 years to look at what's changing.
Okay. Thanks, Julie. Yeah. So I'm going to sign off here very shortly. I've just one question to Hugh, which is, what are you going to do with the horses?
He's staying mute so he doesn't have to answer.
I'm staying mute so I don't have to answer.
All right, I'll get it out of you one way or another. But so I'd like to thank everybody, our 4 panelists, for taking part in the natural resources section. It is such an interesting and complex, incredibly complex world that I feel that we have not stumbled into, deliberately gone into, because we think that it's so important, the future of Australia's natural resources and our management of them. And part of that is most definitely the understanding and modelling of uncertainty. It's been a wonderful last couple of days. You know, we've had a lot of people online. We had, you know, over 200 registrations. Which is really, you know, thrilling because, you know, unlike big data, certainty is not an easy sell. Uncertainty is not an easy sell. It's not a sexy topic. And yet it's so important because the decisions that we make every day are always under uncertainty. And so understanding it and quantifying it is important, but it's difficult to do because being human, we're actually, I don't believe, somebody once said that we were intuitive statisticians. I actually disagree. I think that humans are not good at assessing risks themselves. And so it is difficult for us to do. And I really like the fact that this last group, you talked a lot about just how people rush for the uncertainty and rather than embrace or try to manage and accept that the uncertainty is always there. And I think that that's the message that I'd like to leave, which is at the end of the day, we can only manage away so much of the uncertainty. What's left, we need to embrace and resist the urge to rush to solutions which offer the allure of certainty, because there's really no such thing. So I'd like to leave it there and thank everybody very much for attending and their time. It's been wonderful to listen to such interesting and thought-provoking talks. Thank you.